Hello, this is Michael Riley again from ABA Appliance Channel. Welcome back. I'm going to be going over, I manufacture refrigeration evaporators for SubZero refrigerators, a higher quality than what's always been available. As any techs will know that have been doing service long enough, that the SubZero evaporators tend to have leaks. If you look at the evaporators, you'll see that there's copper in them. It's no secret. They don't try to hide it. Copper in a moist environment corrodes very quickly. And it's just not the proper metal to be using in an evaporator. But I would assume that it's a cheaper manufacturing to use copper in it than it is to use the proper refrigeration aluminum. And manufacturing myself now, I can tell you that that's actually a fact. So it's unfortunate that I got fed up with it after 40 years of doing service, and decided about almost 10 years ago now to redesign the evaporators. And my schooling is electrical engineering with thermodynamics. So I was skilled enough to be able to do so and do it properly. And I've been selling the evaporators around the world now for over 8 years. And not one leak. The only leaks that are caused because I ship them out with 3 leak checks done, pressure and also vacuum, 48 hours each leak test. So there's extensive leak testing before they leave the and go to the customer. When I get a call back that oh, it's leaking, it's because I have them send me pictures, and you're going to hear this over and over in all my videos. They're using oxyacetylene. Oxyacetylene is a cutting torch. It's 3,000 degrees. Now, I guess if a lot of techs knew how really hot it is, they wouldn't be using it. They use it in HVAC because the lines are so big. You can't get them hot enough to flow the solder. 7/8, 5/8, whatever. But in domestic refrigerators, you can't be using oxyacetylene. You got a capillary tube that's very tiny. You just melt it. And the other thing it does, it heats up the joint so bad that it actually brittleizes it and also flows the solder into places that it shouldn't be, because the whole line gets heated up for a long ways when you're at 3,000 degrees on it, especially if you can't get it to seal and flow the solder. And it's difficult to do that sometimes because it's too hot. Okay? You actually burn up and incinerate the flux, so there's no fluxing activity anymore. The flux is not there. It's incinerated by the oxyacetylene torch, 3,000 degrees. So acetylene is the proper gas. And I wish guys would start using the proper gas and do the jobs properly, and then I wouldn't have to tell them that no, it's not leaking. You caused the leak, but I can help you fix it. And there's another video about fixing the repairs, like the copper to aluminum joint that's a weld. It's a filler weld, and I actually manufacture these evaporators, as you'll see in a second. And I actually put together that aluminum to copper weld with an amazing product. I'm not going to mention it here, but there's another video that talks all about it, a couple of them. And when you get that too hot, the copper too hot, trying to solder the heat exchanger in there, it actually melts that joint, the aluminum weld joint, if you keep it on there too long. You can't keep it on there. There is a product that's used in HVAC and commercial that's a heat transfer block paste. It blocks the heat from going to the... They use it to protect reversing valves, metering devices, expansion valves that have plastic parts in them. So you can't get them hot or they'll melt the plastic parts inside. But it's a block paste for heat transfer, and it stops the heat. So if you're going to use the oxyacetylene, you're going to have to use the block paste. You'll find it. Just look it up, block paste, heat transfer block paste. Yeah, it's amazing stuff. But if without it, you're going to melt very likely you're going to melt that aluminum joint. And then you're going to blame the evaporator. And what I do is when you get a hold of me, if you buy my product, I say, look, you can fix it. and you need to fix it, because you need to understand, if you're going to use oxyacetylene, you got to know how to fix the joint that you destroyed. Okay? But there's a product, and it takes about 5 minutes to do it. And you've got the aluminum joint back welded together, no leaks, and you fixed your problem that you created. Okay? Anyway, so the evaporators that I manufacture, I don't manufacture the fin evaporators, and everybody knows, if I explain it, the fins evaporators are the ones that have the fins in it. Okay? It's the tubing and then the fins. Okay? The evaporators that I do manufacture are the single tube evaporators with no fins. SubZero has many of them, and some of them are not available anymore. Now they are available because I manufacture them. So if you need an evaporator that's not available, SubZero, go on my website, refrigeratorpartreplacements.com, and you'll find them on the evaporators page. Okay? You'll also find pictures of what people have done to destroy the evaporators when they use the wrong torch. I'm trying to get it out there to stop doing that. So here's my setup here for making these evaporators. It's really simple. It's right in my kitchen, right at my kitchen table. I'm single, so I can get away with it. Yeah, right, guys? You'd never get away with this if you had a girlfriend or you're married. Believe me, been there. So this is the process. This is my setup. You can see the aluminum tubing here. It's refrigeration aluminum tubing. And you got your bender here. Pretty soon I'm going to get a jig to do this, but I do it manually right now, each bend. And then I've got my doing the weld on these with this aluminum. You can see the heat gun in the background. That's all you need. It's a 350 degree product that welds the filler metal into the aluminum tubing. So when I put the copper inlets in, I'll put the copper inlet in, and I do that with the heat gun and this product. And it just heats up the heat gun's 700 to 900 degrees, so I have to hold it back a little ways. But once it flows, it's 20,000 psi strength plus. It's actually higher than what the kinetic property that they do when they bake them in, okay, in the factories. So what I'm going to do is I'm going to show you the process of how I bend these. I'm going to put this up on the stand here, and I'll show you what how this works. What I do is take the tubing. And if you've never used one of these tubing benders, it's a pretty amazing tool. I'll set this into the tubing bender. I always want to leave a little bit of an outlet before where I'm going to put the copper tube inlet in before I do the bend. I'll put this back, and you can see simply bends the tubing. And there's my first bend. Okay, see how nice that is? You see how clean it is? There's no kinks, nothing. It actually stretches the metal as it bends it, so it's just like a factory bend. Okay? And then what I'll do is I'll straighten this out. I'm not going to do this whole thing. It would take about an hour to do this. I'll measure out what I need for the next bend, and then I'll put this back in the jig, and I'll do the same thing. And I'll bend it. So then I have, you can see that I'm going to have I'll have this bend, then I'll have another bend here, and I'll just keep going until I get the whole evaporator done. Okay? Now I'm going to do that. I'll just stop there. There's no reason to continue on. And once I do that, there's a nice tool here that allows me to it's a swaging tool, okay? See, it's smaller on the one side and it's a little bit bigger on the other side. Starts out smaller, and this is a swaging tool. And the nice thing about this, there's a pros and cons of this swaging tool. The nice thing is that it graduates up and gets it nice and round. The problem though, is when you push on this, see how it spreads it apart? So what it tends to do is, if the tube's on here, is it actually tends to spread the tube on one side and flatten it out on the other side. So what you have to do when you use this tool is you have to rotate it as you're squeezing gently. Rotate it and keep the whole tube moving back and forth so that you don't get it flat on one side and round on the other. What I do is I'll push this in here. Okay. If you look here, it's not going to fit. Okay. But as I work this in here, the aluminum's so soft, you see it just push in there? Okay? Just pushed right in as I turned it. Now if you look at that joint, you'll see how it's just a little bit beveled right here. Just a little bit on the end. Now when I squeeze on this, I'm turning it at the same time. Turn it at the same time as you squeeze. Don't squeeze too hard or you go too big. Okay? Now if you look at the joint, you can see a little bit of a rise here on the end. From here to here, there's a little rise. It's almost like there's a circle. It's almost like there's a little circle right there. But it rises up and it's bigger there. So what I do is I keep testing this with my 1/4-inch tubing. And I'll be darned, it's perfect. Okay? The tubing is perfect. Okay? Then what I do is take the product that I have, and I will do that in another video. I will take the heat gun and I'll heat it from below. I'll heat it from below and I heat it back on the tubing. I'll heat it on the tubing, on the aluminum, and then I'll heat it over here on the copper. On the aluminum, and then on the copper. Okay? On the aluminum and the copper, as I put the flux on this joint, and then I take the rod and I start putting the filler in. When it turns honey brown, they call it. The heat from the heat gun, and I might have the heat gun back here. Okay, a little ways away, because I don't want it to get too hot. And I'll keep heating it until that flux turns a honey brown. and then I touch it with the rod, the filler metal, and it goes all the way around, and I'm off of it. 20,000 psi strength. It's amazing. Okay, so once I do that, then I'll do the other end down at the bottom of the evaporator. When I get down at the bottom of the evaporator with all the tubes, then I'll do the other end of it and put the tube in the other end of it. Okay, once this is all bent and everything. This isn't bent right now, but I'm just saying. Okay, so I'll put another piece in. And I usually put about a 6-inch piece of copper in. Usually about 6 inches, so that there's plenty of room between the solder joint from the heat exchanger, which is going to be down here, and the torch being on it, so it can absorb some of that heat and not melt this aluminum weld. Okay, but if you stay on there too long and you have a wrong torch, you're still going to melt this, just like on any evaporator. Okay, you don't want to have a wrong torch and too much heat. Okay, so the next thing that I'll do, once I get both ends on it, is I will take this process adapter. This is what's called by Rtnoww. It's a process tube adapter kit. It's about $300. Let me show you what's inside the box here. These are different sizes. If you look at the ends of those, see the little tiny one here? It'll go to a really tiny tube, that size. Okay, next one, that's a pretty good sized tube. That's about 3/8, 5/16. And the one that's in here right now is 1/4 inch. You see how this works? Is that there's a rubber grommet inside. Both sides of this has holes in it. So all this does is squeeze it together around the tube. Okay? These are the sizes right here. Okay, you've got 3/8, 5/16, 1/4 inch, and 3/16. That's the size tubes that you can actually attach to with this. Okay. So because this is larger than a 1/4 inch, what I do is once this is soldered in here, on the other end of it, I'll put this on, just like that. And I'll tighten this up, and this is just like it's inside here. It's soldered in here. Okay, so it's soldered in on both ends. Okay, just assume that that's welded in. Okay, and then I'll put the process of tube adapter on here. I'll put one on both ends of the evaporator. On both ends. Okay, because there's going to be a copper tube on the top and the bottom of this evaporator. Then what I do is I'll take my gauges, I'll take my gauge set, and I'll attach the gauges to both ends of the process adapters. Okay? This is attached to the other end at the bottom of the evaporator. This is attached to the bottom of the evaporator. This is attached to the top of the evaporator, where this is welded in. This is normally welded in here. Okay? So then I've got the gauge hooked up, and this one's hooked up to the bottom of the evaporator, to the same outlet copper tubing that's at the bottom of the evaporator. We didn't make it in this because I didn't make the evaporator. Okay? But then I'll take take my gauges, and if you're a sealed system guy, you know that this line right here, this is the one that goes to the evaporator. This one here is goes to the vacuum pump. This one here goes to the vacuum pump. Okay? So I'll hook it up to the vacuum pump. Okay, let's take that out a little bit so you can see what's going on. I'll hook this up to the vacuum pump. The center line off the gauges. And then I'll turn the vacuum pump on. And I'll suck down this evaporator. I'll suck this down into a vacuum. Okay, so the vacuum is going to be below zero. Okay, you got zero, and then you get the vacuum below zero. That's inches of vacuum. Okay, and I'll get it down to 28.6. Which is the max vacuum, and I'll leave it on there for about 10 minutes. Evacuating. After about 10 minutes, I'll go ahead and shut it off. Turn the pump off. Excuse me. I will close the gauges first, then I'll turn the pump off. Okay, that's important. Make sure you close the gauges, all the valves in the gauge. Make sure they're all closed. Make sure all your lines are tight, so you don't lose any vacuum. Make sure these are all tight. That's one of the biggest problems with people when they do this is they'll have a hose loose. And it just starts leaking, and it's like, oh my God, I've got a leak in the solder joint. And then they go back and start messing with the solder joints, and there's no leak. It was the hose that was loose. Okay, so be 2 and 3 times check your hoses and make sure there's no leak. That you have the hoses tight. Okay, I've done it myself. It's really common. Even when you're moving the tubing around and stuff, sometimes it can become loose. So get it really good and tight. Don't crank down with pliers. You're going to ruin the seal inside. But get it good and tight. Turn the gauges off, the valves on the gauge, turn the vacuum pump off. Now leave it for I leave it for 48 hours. Okay? And if this needle stays in a vacuum for 48 hours, if it stays all the way down below zero in a vacuum, exactly where it was when you evacuated it, 48 hours later, or 20 minutes or half hour later, you don't have a leak. And this is such a small tubing, this evaporator, that you don't have to leave it for 48 hours, 24 hours. You don't have to do that. Because you're going to have a leak right away. It's not like it's going through a whole refrigerator system. And it might have oil in it that might slow the leak down or whatever. This is going to come out pretty quick. So if it comes right back up to zero in just like 5, 10, 15, 20, 30 seconds, or a minute or 5 minutes, there's a leak. And it's just how big the leak is by how long it'll take. But it's going to happen very quickly. Okay? If you have it, in this case, you're not going to have it come up about 2 or 4 inches of vacuum and not get to zero. That's going to indicate that there's contamination in the system. And unless you put a bunch of oil in this tubing before you soldered it and everything, you're not going to have that. It's not going to happen. In a regular sealed system, you're going to see that. You'll see it maybe drop 2 to 4 inches or come up 2 to 4 inches of vacuum. It loses that vacuum because contamination will absorb vacuum. It won't bring it up to zero. So if it stays there at like 26 or 24 inches of vacuum instead of 28, almost 30, if it stays at like 24 or 22, it doesn't go up anymore to zero, it doesn't go to zero, then you just need to evacuate it longer, okay? Guys get too carried away, especially these new guys with watching YouTube and stuff. On domestic refrigeration, we don't worry about taking it down to 200, 400 microns. You know, unless you're just getting carried away, they're not really that critical of a system. The metering device is a capillary. The metering device is where the issue comes into whether you have to really worry about how far down in microns you go. And that would be like an expansion valve. They're really critical because if there's anything in there at all, you need to really get it down micron value, or up, okay, 200, 400 microns. So, but with the refrigerators and freezers in the domestic and the in-home refrigerators and freezers, it's not that easy. Just get it down into a vacuum. Make sure it stays down at what looks like 30 inches. It's not possible, but it pegs there and it looks like it is. 28.6. And it stays there. It doesn't move. If you leave it there for a half hour and it doesn't move, your system's good. Okay? Don't concern yourself with microns. It's just ridiculous. So, guys will argue that point with me, and I've been doing this 40 years. It doesn't matter in domestic refrigerators, okay? And freezers. It just doesn't matter. It's the metering device that matters about, okay? And we have a capillary that it's not that sensitive. It's not like a expansion valve or some of the commercial types. So, anyways, this is the process. What I do is I make about 12 different models of these evaporators, ship them around the world, and they're actually on, like I said, my website, refrigerator part replacements. That's refrigerator part replacements.com. Okay. And I did have a different website, but SubZero attacked me and forced me to take it down. They went to the registrar of domains, and it was just ridiculous. I'm selling their products, and I'm actually selling their original OEMs also, a lot, most, except the evaporators that I manufacture. All the rest of the parts I sell are OEM. And they're getting tremendous sales from me, but they just got all bent out of shape. Didn't even say SubZero, the domain name, the website address. It was just letters, and they got all bent out of shape, and that was a few years back. And so that's why I went with the longer one, a general website name, refrigeratorpartreplacements.com. So this is what I do. If you have questions about it, if you'd like to make your own evaporators, contact me. I'll walk you through it, and what tools to get and whatever. The last thing that I do is I put heat shrink tubing on here, okay, on the joints where they weld. And one of the things that I keep mentioning, the other thing that let me say this first. After I evacuate it, what I do is I will put Freon in it, about 50 pounds, and then I'll leak test it. The leak detector. I'll leak test it just as a second test to make sure if the vacuum didn't catch it, that 50 pounds, and you'll get bubbles right away. It's just like soap. Okay? So if anything comes out of the joint, you're going to get bubbles, and you're going to know that, the vacuum pump didn't catch it. Now, one other thing that I want to mention, I'm seeing a lot of this. Guys are going on YouTube instead of learning the proper way, and they're just going by other guys' ways that are not the most effective. This is emery cloth. Okay, they have like a screen hole, emery cloth with holes in it. Also, it's like a greenish blue. But this is emery cloth. Okay, see how fine grit that is? That's emery cloth. Do not use a wire brush. Don't use a wire brush. Okay, if you use a wire brush, it's no different than doing this on the tubing. What's happening here? Do you see between my fingers where I'm missing the tubing? That's what a wire brush does. It doesn't get it all the way clean. This does. This wraps around and gets it totally clean everywhere and there's the grits on the whole paper. Okay? Guys will have a problem with the flow soldering. With the solder flowing. The reason? It's not clean enough. And they're like, well, I wire brushed it all like crazy for a half hour. But that's not the problem. You can do it as long as you want. But there's gaps between the wires. So there's still going to be black spots on there, no matter how much you do it. Okay? There's very likely still going to be black spots on there that's not clean. And once you put the flux on there, you're just putting flux on a dirty spot. And the solder is not going to flow there. Okay? Think about it. So if you have problems doing that, throw your wire brush away. Or trade it on the sink for your wife's regular brush. Take her brush and put the wire brush there and you see if she likes it and think that's funny. Anyways, so don't use a wire brush to clean these joints. Okay? Don't. The other thing that I'm going to point out that's critically important is when you clean this joint, you're going to take this and you're going to clean the end of this. Okay? That's great, but the problem is, and that's not clean, I just barely touched it. Go all the way around. You can see how it's just bright, and there's no gaps between where it's clean and not clean. You can see it's shiny everywhere, okay? Because the grit gets everything. But you're not going to seal still. Look at the end of that tube. That's not clean yet. Guys will not clean the end of the tube. You guys, that's where the other tube goes in. That's where the solder flows. That's where it seals on the end. You have to go across. Go across the tube. Okay? Across the end of it. Get that whole end clean. Okay? Now look at the end of that tube. Remember how black it was before? Look how shiny the end of it is. That's where the solder's going to flow. And now it's going to stick right on the end. It really almost doesn't matter that you clean this, except for just a very small end of it. But it's always best to clean farther up. Okay? But this is the most critical part. Clean the end. And then you clean the other tube real well. And when you put the flux on there, and put the heat right on the shoulder of the joint, you put the heat right on the shoulder of the joint. Not way back here, right on the shoulder of the joint. And flow the solder on here, and when it's clean and there's flux on it, that solder is going to flow around in a second. And you're going to pull the heat off and the solder off, and it's going to be a nice, smooth, flat solder joint. It's not going to be bulging and a bunch of solder on there because you keep touching it because you didn't go all the way around. That's why it doesn't go all the way around. If you have this nice and clean, put flux on, and if you have solder that has flux in it, still use white paste flux. Okay? When you put the heat on, it starts to get red, touch the solder on there, boom, it just wraps around. It follows, it chases the flux wherever the flux was. And you're off of it. And you have a perfect, just like a factory solder joint. Okay? That's why you can't get your solder joints perfect. It's because you're using a wire brush possibly. You're not cleaning the end of the tube. Okay? Which is really the most important part of it. That's where the solder sits. You don't see solder up here when you're done, unless you're really screwing up. Okay? And I know a lot of guys do find that because you're heating it so much because you didn't get it clean. Okay? So, there's some other tips. There's going to be a lot more tips in all my videos about this kind of stuff and getting this stuff right so that it makes your job a lot easier. You're not filling it full of Freon and then, oh no, I have a leak. The first time you solder it, you're going to see it wrap around and go, wow, you feel good about it right away. And you know what I'm talking about, because if it doesn't want to flow, it's aggravating. You keep having to put heat on it, keep putting heat on it. That's where you melt. the aluminum joint. Because you keep putting heat on that joint down farther down to get the solder, the heat exchanger soldered into the copper, but it's not clean. And you end up melting the aluminum joint, the aluminum weld. Okay? Now you're screwed. But now you're not, because there's a product, and look through my channels and you'll see it, for repairing the aluminum weld. So, got you covered all the way around. I've been there, I've had the problems myself. That's why I've corrected the issues for myself over the years, and now I want to share it with everybody else so that it makes things easier for you. Okay? So, let's check out my check out all my other videos. Please do subscribe to the channel. I'm going to have a lot more updates for you, and material and videos, things that can be very helpful for you. And actually, just like these evaporators, if the only thing that you don't know is where to get this tubing, and it's really hard to get. You can't just use whatever tubing you want when you make these evaporators. There's a lot of different factors involved, but you could end up making the evaporators yourself if you're like me, that nothing stops you. You saw how it's done. It's not difficult. So keep watching. Please subscribe. Like the video if you like it. I hope you do. There's a lot of information in it. And we'll see you soon. Okay? Once again, my name is Michael Riley, and my channel is ABA Appliance. All right? Take care. Thank you.